Euclid Book 1, Proposition 3 is where you have a line segment, in this case BC, and you have a random point, in this case point A, but from point A there's a ray going off in some direction. And the goal is to put a point onto that ray so that A to that point is the same length as BC using the collapsible compass. And here are the steps. The first step is to make equilateral triangle with AB as the base. The second step is to make a circle with B as the center and radius BC. The third step is to extend HB in this case with a ray. The next step is to see where that hits the circle right here. Now we're going to make a circle with the vertex of that equilateral triangle, and it's going to go to that same point you just made. Then you extend this side of the equilateral triangle, and where that extension hits the bigger circle, AJ will be the same length as BC. However, AJ is not in the right direction, so we're going to need one more circle. Center A goes through J, and where that circle hits the line, the ray, here at point K, I've now finished. If I want to check, I just measure BC, and see it's 1.69, and I measure AK, and it's also 1.69. So I know there's a lot of things going on in there, but you can move B and C around, but not too much. But you can move around a little bit, move that B around, and you can see, oh, for some reason I lost that point. Here's that K point again. So here I'll measure BC, now it's 1.78, AK is also 1.78, and if I move B around a little bit, you can see those two line segments change and continue to be the same length.